Hey guys, this video is going to cover 11.4. 11.4 is pretty simple. It's mainly just vocab. Homework should take you less than 10 minutes. So with all that said, let's get started. All right, so just a reminder, a polygon is a plane figure enclosed with sides and angles. Now there's two parts with this, well, kind of three. So when I say a plane figure, I mean a flat two-dimensional figure, something that you can draw on a piece of paper, like your piece of paper is your plane. So we're not talking about three-dimensional figures. We're not talking about one-dimensional figures. We're talking about two-dimensional figures. So that's what plane figures mean. And it's enclosed with sides and angles. So if it's enclosed with sides and angles, that means anything circular would not be considered a polygon. So if I just do these just to kind of jar our memory, a rhombus, is it a plane figure? Well, a rhombus is. So yes, it is. It's a plane figure and it's constructed of angles and sides. I'm not going to write all that down, but read the definition and that is why it is yes. All right, so a circle is not a polygon and it's because there are no angles or sides. Okay, so a circle is not. And then this rectangular solid is also not because it is not a plane figure, meaning it is not two-dimensional. This is a three-dimensional figure, and therefore it is not a polygon. So just kind of a refresher of what a polygon is. All right, so we're going to go into three-dimensional figures. A lot of it's how we name them, the parts of them, things like that. A polyhedron is what we are going to go over first. So a polyhedron, guys, it's going to be a three-dimensional figure that's bounded completely by polygons. Okay, so all sides of this three-dimensional figure are composed of polygons. Now, the polygons do not have to be the same shape. Like, as you can see down here, here's a trapezoid, here's a rectangle. That's still a polyhedron. So it's just a three-dimensional figure where everything is constructed of polygons. So like a cylinder would not be a polyhedron because, once again, its base is a circle, and circles are not polygons, so it wouldn't be bounded completely by polygons. All right, so the parts of a polyhedron, guys, and here's kind of a visual down here. So a face would be the flat surface of the polyhedron. So like this top piece here, this would be a face. This side piece over here would be a face. This front piece would be a face. So faces are, I probably should have written, these are all polygons. They're two-dimensional figures. Okay, so the edge of a line segment is where two faces meet. So like this piece right here would be an edge. This line would be an edge. This line, this line, this line. So a line segment in which two faces intersect. And edges are lines. Or segments, maybe I should say. Line segments. Okay, now a vertex would be any point on a polyhedron where three or more faces come together. Or three or more faces or edges, really. Let's do edges just because it'd be a little easier. Three or more edges meet. Okay, so right here would be a vertex. This point here. Okay, this point here would be a vertex. This would be a vertex. This would be a vertex. This would be a vertex. So it's where the faces come together. But not only where the faces come together, it's where the edges come together. It's the corners, if you will. So this would be points. Ooh, bad typing skills. Okay, so you go from polygons to line segments to points. All right, so here we go with polyhedrons. Okay, now polyhedrons are named according to their bases, and we will get there later. But a polyhedron in which both bases are congruent get rid of some of this. Congruent and parallel. And the faces have to be rectangles. And if they are, that would be a prism. So a prism has to have two bases. So generally it's top and bottom. Sometimes it could be left and right. So in this case, the hexagon is the base. So you have a hexagon, and then the other hexagon at the other end has to be both congruent and they have to be parallel in order for this to be a prism. And then each of the faces around it are going to be rectangles. Okay. The bases can be whatever shape you choose, but the non-bases have to be rectangles for a prism. A pyramid is an object. This is also a polyhedron. It is an object that has a polygon at its base. And then the triangles, see, notice the other ones are the triangles where it comes up to meet at the, now these, there's two letters for this. This can either be an apex or a vertex. You hear both quite a bit. So either one of those will be fine, apex or vertex, and that's just this top point where the sides all come up to a point. These are non-polyhedrons. So a cylinder is a non-polyhedron, of course, in which the bases, first of all, they're circles. And once again, just like before, those circles have to be both parallel and congruent. Parallel and congruent. All right, a cone is also a non-polyhedron, and the base is circular. So the base is circular, and then it converges up to an apex or a vertex. Once again, that's kind of interchangeable. The sphere down here, guys, this is also a non-polyhedron. These are all non-polyhedrons because they have circles on them. Oh, no, non-polyhedron, which is perfectly round. It's three-dimensional, and this is all points, not just points on a plane, that are equidistant from a center. So remember when we did circles, we did all points on a plane that are equidistant from a fixed center point? Well, this is all points not on a plane, just all points in all planes that are equidistant from that fixed center point. All right, these are just pictures, guys. These are polyhedrons, these are not. So, like I said, polyhedrons are named according to their base. Okay, so this is a polyhedron. Okay, it has rectangular sides. It has two bases that are congruent and parallel. So this would be yes. And if I look at this, the base is a rectangle. So I would call it a rectangular prism. Okay, so this would be a rectangular prism. This is also a polyhedron. And the reason it's polyhedron, it has all polygons. This is a pyramid, though, because it goes up to a point. And pyramids are still named according to their base. So this base has how many sides? So 1, 2, 3, 4, 5, 6. So it's a six-sided base. So it's a hexagonal base. So I would say this is a hexagonal pyramid. There we go. Yes, it's a hexagonal pyramid. This here is not a polyhedron, and the reason it's not a polyhedron because we have a circle up top, but if we still wanted to name it, I said we don't have to. This is just a cone. You don't have to write circular cone because all cones have a circle as its base. All right, cross sections. So cross sections are kind of confusing a little bit. Not too bad. Good thing is we're not going to really do anything other than have a couple homework questions on them and then move on. So the cross section is the intersection of a plane and a solid. So if we take this three-dimensional figure and we cut like a slice through it, what shape would be on that slice? So here we have a 1, 2, 3, 4, 5, a hexagonal prism, and we cut right through the middle of it, and we're left with a hexagon. Okay, so see, that's what's listed here in purple. This would be the hexagon. So we go from 3D, these are always 2D shapes. Okay. So if we look down here, we have this rectangle, and it looks like we're kind of slicing maybe at a little bit of an angle. Notice in purple here, all we're left with is a triangle. Okay, so over here on part C, we have a cylinder. I slice straight down. So remember, if I look at this plane going down, what two-dimensional figure do I see? Well, let's look in purple. Right? It is a rectangle. Hopefully that's not too bad. All right, axis of revolution, guys. So an axis of revolution is just a line or an axis where a shape is rotated around. Okay, so we're going to rotate it around. And then the solid of revolution, this is the the three-dimensional figure formed by rotating a two-dimensional figure around. So let's look at these. So here's my axis of revolution. Remember, my axis of revolution would be a line. So this is my axis of revolution here. And then this over here is my axis of revolution. Okay, now I'm going to take this plane right here and I'm going to rotate it around this axis. I'm going to go around it and around it and around it. And if I keep going around and around and around, what happens is I get this shape. I'm going around like this, and I'm going all the way around like this. And what I end up with a cylinder. So I end up with see, it's a cylinder kind of on its side. So it's cylinder with a radius of 4 and a height of, well, if these are your bases, these are your circular bases, this height is 9. Remember, the height is the distance between the two bases. All right, so over here, I have this triangle, and I'm going to rotate it around this axis. So when I rotate around this axis, this is going to come all the way over to here. And then this isn't going to move. So it's going to look something like this. So when I do that, you can see that that would be a cone with a radius of 2 and a height of 5. Radius of 2 and a height of 5. All right, well, that's all for this lesson. Homework is on big ideas. Literally, it should take you probably less than 10 minutes. It shouldn't give you problems whatsoever. Please reach out and let me know if you have any questions. See you guys.